All right, law of large numbers. As the number of trials
I don't see pattern 3.
of a random event increases, the difference between what we expect to see and what we actually see approaches 0. Commercial airplanes have an excellent safety record. Nevertheless, there are crashes occasionally with the loss of many lives. In the weeks following a crash, airlines often report a drop in the number of passengers, probably because people are afraid to risk flying. A travel agent suggests that since the law of averages makes it highly unlikely to have 2 plane crashes within a few weeks of each other, flying soon after a crash is the safest time. What do you think?
It doesn't matter.
It's
Like,
not a real.
It's superstition. Not really.
Yeah, not real.
Yep, there's no such thing as the law of averages.
I feel like that might cause. Oh wait, you're in the sky. It's not like you're gonna run into that. But like, I feel like that's gonna like cause people to like not be on as high alert for stuff. Could actually be worse.
A bird
Because
can get
it's
stuck
the
in the
same.
engine.
That's true. I'm just saying, like, you're not gonna probably see like things crashing.
They're misusing the law of large numbers. And the law of large numbers only applies to large numbers of trials. So it's long term, not short term. If the airline industry proudly announces that it has set a new record for the longest period of safe flights, would you be reluctant to fly? Are the airlines due to have a crash?
Sorry, Mr.
I mean, they aren't due to have a crash,
It's
but like,
Why?
well, I mean,
Does
No,
one
it's not
plane
that.
crashing or not crashing affect another?
no.
No. Well, not
So
unless
they
it's
are?
or something.
Independent.
Independent. Probability is independent. So one plane not crashing does not affect the probability of another plane crashing. Just realized there's a column or row left off of this table down here, so I'm going to add it in.
I forgot you.
You're like, what are you crunching?
All right. Many stores run secret sales. Shoppers receive a scratch-off ticket at the checkout to determine their discount. The store is required to reveal the distribution of discounts available. Which of these probability assignments are legitimate? So each row is like a set.
I would probably have to say, yeah. What is going on?
Why?
The it totals up to 1, and A and B don't total up to 1, and only the
If you
C.
add all
Well, I
of
mean,
them
technically
together,
C
they
does,
get
but, like,
50%.
I don't think you're able to have a negative probability.
Correct. So A is less than 1 if you add it up. B, if you add it up, is greater than 1. C, we have a negative probability, which we can't have. And D is exactly equal to 1. Because remember, 0 is can't happen. Our probability has to be in that range, 0 to 1. And 1 is that it must happen. So just as a refresher on that. All right, a large introductory statistics lecture hall. The professor reports that 55% of students enrolled have never taken calculus. 32% have taken only 1 semester of calculus, and the rest have taken at least 2 semesters of calculus. What is the probability that you choose a partner who has studied? And then we're going to look at those different things. So, no semesters or no calculus at all, there's 55%. 1 semester is 32%. And 2 or more semesters is 13%. So the good news is that adds up to 100.
Let's go.
So, what is the probability that you choose a partner who has studied 2 or more semesters of calculus?
0.13.
How did you get that?
There's a 13% chance of one who has 2 or more semesters of calculus, and we have to convert it to a decimal.
Yep. So, 0.13 or 13%, since that's where we got the number from. 2 or more would be, obviously, that's just information that was given. All right, how about some calculus? What does that imply?
0.45.
Huh?
0.45.
How did you get that?
I added the percent that have taken 1 semester and 2 or more semesters.
Yep, so some calculus is 1 or more semesters. So that's going to be 0.32 plus 0.13, which is 0.45. How about no more than 1 semester? No more than 1 implies what?
Oh, I thought
Like-
you said just
1 or less.
Okay, so they could have 0 or 1 semester, which would be 0.55 plus 0.32, which is 0.87. All right, probability of repeated events. If 2 events, A and B, are independent, meaning that the outcome of A, bless you, does not change the probability of B or the outcome of B. Then the probability of both occurring is the probability of A or B, which remember we can write as the probability of A union B. is the probability of A plus the probability of B. Alright, we'll probably go through this one and then we'll just probably stop there. The next problem's pretty long. You are assigned to be part of a group of 3 students from the intro stats class from exercise 3. What is the probability that of your other 2 group mates neither has studied calculus? This is going to be like the red light problem. So we have that the first person in your group hasn't studied calculus. What's the probability of that?
55.
Yep. And what about the second person?
Also, so we're multiplying those.
So we're going to multiply 0.55 times 0.55, which is Nathan has it. Like point something.
0.3025. 0.3025.
All right, how about the probability that both have studied at least 1 semester of calculus?
At least one. At least. Let's see.
What does at least 1 mean?
So you gotta take into account that 32% with 1. So it could be 1 or more.
And 13%.
So, yeah. So you gotta do 32.
Which we found up here to be what?
0.45.
0.45. So 1 or more semesters was some calculus. So that's going to be point.
0.5.
Yep.
Point 2025.
Oh my gosh, that's next year.
363 days away. It's a leap year, in case anybody's trying to figure out the math there.
Yep.
All right. This one's going to get a little dicey.
Yeah.
At least one has had more than 1 semester of calculus. That means one of the people has had more than 1.
But it also could be both.
Okay, right. But the second person could have what?
None. 1 or more.
Yep. None, 1, or more. All right, so some things to note here. We're going to make a chart. So 2 or more, we know has to be the one person, right?
Yes.
And then the other one could have 0 or 1. So if the first person has 2, we know that the second person then could have 2 or more, or they could have 0 or 1. Down here, if the first person has 0 or 1, the second person could have 2 or more, or the second person could have 0 or 1. However, according to what it says, that can't happen. We can't have both 0 and 1. So we're going to look at the math for each of these things individually. So 2 or more and 2 or more. 2 or more's percentage is 0.13, or the amount is 0.13. So it's going to be 0.13 times 0.13. And we're just going to leave that there for a second. We don't need to multiply anything yet. The second one is 2 or more and 0 or 1, which is going to be 0.13 and 0.87. Are we tracking so far?
Yes.
The next one, the first person has 0 or 1, which is 0.87. And just to be clear, the 0.87 we got from part C of number 3. That's why I'm not doing the math for it. If we hadn't already done that part, we would potentially be having to do that separately. Then 2 or more is 0.13. Then 0 or 1 for both is 0.87 and 0.87, but we know that for our scenario that can't be possible. So there's a couple ways we can do this problem. Okay, there's 2 ways. So I'm going to show you both so that mathematically you can see it. We can either take these multiplication factors and add up the ones that are possible. Okay, we know that one of them has to have 2 or more. So basically, right away, we can get rid of that one because we know that that one's not possible. Okay? So I can then do 0.13 times 0.13 plus, now these two, 0.13 times 0.87 and 0.87 times 0.13, you would agree are the same, right?
Yes.
So I can do 2 times 0.87 times 0.13 just to not have to write so much. And I can get this value. So what decimal do you get if you do that? .2431. Okay, so that's one way we could do this problem. But what is the other thing that we said about when we see the word at least? Think. It's the last thing we wrote in the notes.
It's the
Complement. Okay. So the complement of at least one has more than one semester would be 1 minus the probability that none had 2 or more semesters, because they could have, anyways. So that would be 1 minus this bottom one that we marked off, 0.87 times 0.87. And what is that? So, you could have done this problem without doing the diagram, but one, I like you to visually see the diagram because there are going to be some where you're going to need a diagram potentially. If you didn't do the diagram, you pretty much have to do the complement method, or you might as well have just drawn the diagram if you're going to do the other one, because it would have been easier to see it. But, anyways, we'll stop there for today. Probably finish tomorrow. We'll go from there.